How does GPS know exactly where you are? Part 1. What your phone is actually doing. You open a map, and within seconds, a blue dot appears almost exactly where you are. It may even know which road you are on and which direction you are moving. It feels as though satellites are watching you from space. But GPS does not normally work that way. The satellites are not looking at your phone, and your phone is not asking them, "Hey, where am I?" Instead, the satellites continuously send signals toward Earth. Your phone listens to those signals and works out its own location. In other words, the satellites provide the clues, but your phone solves the mystery.
Part 2. What the satellites send. GPS stands for Global Positioning System. It uses satellites orbiting high above Earth. They are positioned so that several of them can usually be detected from almost anywhere outdoors. Each satellite repeatedly broadcasts a message containing two important pieces of information: its position in space and the exact time the message was sent. The message is basically saying, "I am here and I sent this signal at this exact moment." The satellites carry extremely accurate clocks because the entire GPS system depends on timing. Your phone receives the signal a tiny fraction of a second after it was sent. That delay is the first clue to your location.
Part 3. How time becomes distance. GPS signals travel at the speed of light. That is incredibly fast, but they still take a small amount of time to travel from space to your phone. Your phone compares the time the signal was sent with the time it arrived. It then calculates, how far could this signal have traveled during that amount of time? That gives your phone an estimated distance from the satellite. Suppose your phone calculates that it is about 21,000 kilometers away from one satellite. That still does not reveal your location. It only means you could be anywhere at that distance around the satellite. Imagine someone telling you, "You are exactly 5 kilometers away from me." You now know your distance from that person, but you could still be north, south, east, or west of them. One satellite is not enough. Your phone needs more clues.
Part 4. How several satellites find one location. Your phone now receives a signal from a second satellite. It calculates its distance from that satellite too. A third satellite reduces the possible locations even further. The easiest way to picture this is with circles on a map. Imagine that the first satellite tells you that you are somewhere along one large circle. The second satellite creates another circle. The third creates another. The point where the distances agree is your location. In real life, the calculation happens in 3 dimensions, so the shapes are closer to enormous invisible spheres surrounding the satellites. This method is called trilateration. Your phone is not measuring the direction of the satellites, it is measuring its distance from them. But there is one more problem. The clock inside your phone is not perfectly accurate.
Part 5. Why 4 satellites are usually needed. GPS depends on extremely precise timing. Even a tiny clock error can create a large location error because the signals travel so quickly. The satellites use atomic clocks, but your phone does not. Putting an atomic clock inside every smartphone would be slightly inconvenient and probably terrible for the price. Instead, the phone uses another satellite to correct the timing mistake. It normally needs at least 4 satellites to calculate 4 things: its position from side to side, its position from north to south, its altitude, and the error in its own clock. The 4th satellite allows the phone to adjust the clock error and find a reliable 3-dimensional position. Your phone often receives more than 4 satellite signals. The more useful signals it has, the more accurately it can compare the measurements. So the basic idea is simple. One satellite gives a distance. Several satellites narrow down the position. The fourth helps correct the phone's clock, and together they reveal where you are.
Part 6. Why GPS sometimes gets it wrong. GPS is accurate, but it is not perfect. Outdoors with a clear view of the sky, your phone can often locate you within a few meters. Inside buildings, tunnels, or crowded cities, the result may be less accurate. The main reason is that satellite signals are weak by the time they reach Earth. Walls, roofs, mountains, and trees can block them. Tall buildings create another problem. A signal may bounce off a building before reaching your phone. That makes its journey slightly longer. Your phone may then think the satellite is farther away than it really is. This is why the blue dot sometimes appears on the wrong street or briefly moves through a building. The phone is still performing the same calculation, but it is working with imperfect signals. Part 7. Why your phone uses more than GPS. When you open your map, your phone does not rely only on satellites. It may also use nearby Wi-Fi networks and mobile towers to estimate your general area. This is especially helpful when you are indoors or when GPS has only just been activated. Your phone's sensors provide more information too. The compass helps determine which direction the phone is facing. The accelerometer detects movement. The gyroscope detects rotation. When GPS briefly disappears, such as inside a tunnel, the phone can use your previous direction, speed, and sensor information to estimate where you are going. That estimate may slowly become inaccurate, but GPS corrects it once the satellite signals return. The blue dot you see is therefore usually the result of several systems working together. Satellite signals determine your position. Wi-Fi and mobile towers help locate you faster. Internal sensors help track your movement and direction.